Astronomers have uncovered the first evidence of water vapor in the atmosphere of Jupiter's moon Ganymede by using new and archival datasets from NASA's Hubble Space Telescope, reports PTI. According to the study published in the journal Nature Astronomy on Monday, the water vapor forms when ice from the moon's surface turns from solid to gas. NASA says that the previous studies have offered circumstantial evidence that Ganymede, the largest moon in the solar system, contains more water than all of Earth's oceans. However, according to the US Space Agency, temperatures there are so cold that water on the surface is frozen solid. Ganymede's ocean would reside roughly 160 kilometers below the crust. Therefore, the water vapor would not represent the evaporation of this ocean. Astronomers re-examined Hubble observations from the last 2 decades to find this evidence of water vapor. In 1998, Hubble's Space Telescope imaging spectrograph took the first ultraviolet images of Ganymede, which revealed colorful ribbons of electrified gas called auroral bands, and provided further evidence that Ganymede has a weak magnetic field. The similarities in these UV observations were explained by the presence of molecular oxygen. However, some observed features did not match the expected emissions from a pure oxygen atmosphere. At the same time, scientists concluded this discrepancy was likely related to higher concentrations of atomic oxygen. Lawrence Roth of the KTH Royal Institute of Technology in Stockholm, Sweden, led the team to measure the amount of atomic oxygen with Hubble. The team's analysis combined the data from 2 instruments, Hubble's Cosmic Origin Spectrograph in 2018 and archival images from the Space Telescope Imaging Spectrograph from 1998 to 2010. Contrary to the original interpretations of the data from 1998, they discovered there was hardly any atomic oxygen in Ganymede's atmosphere. Roth and his team then took a closer look at the relative distribution of the aurora in the UV images. Ganymede's surface temperature varies strongly throughout the day, and around noon, near the equator, it may become sufficiently warm that the ice surface releases some small amounts of water molecules, the researchers said. The perceived differences in the UV images are directly correlated with where water would be expected in the moon's atmosphere, they said. Roth mentioned that the molecular oxygen had been observed so far. This was produced when charged particles erode the ice surface. The water vapor that we measured now originates from ice sublimation caused by the thermal escape of water vapor from warm, icy regions, he said. The finding adds anticipation to European Space Agency upcoming mission Jupiter Icy Moons Explorer, JUICE. Planned for launch in 2022 and arrival at Jupiter in 2029, JUICE will spend at least 3 years making detailed observations of Jupiter and 3 of its larger moons, with particular emphasis on Ganymede as a planetary body and potential habitat. Our results can provide the JUICE instrument teams with valuable information that may be used to refine their observation plans to optimize the use of the spacecraft, Roth added. News Desk, Kaumudi English.